Okay, I guess we're ready to get started. So firstly, I would like to welcome all of y'all to Enterprise RAG, which is sponsored by Support Vectors, presented by the AI Collective, and hosted at Snowflake at this lovely location. I don't know how many of y'all have been here before, but this is my first time and I love the location. So I hope y'all feel the same way about this. We're really excited to have all of y'all here today. So just to get some introductions into the way, I'm Atisha Rajpurohit. I am here representing the AI Collective. We're the ones bringing this event to you. Um, I have had a career of about a couple of years and everything in different kinds of quantitative analysis, um, um, uncertain probability estimations, and now I'm finally pivoted into AI engineering, which explains my interest into RAG. I'm here from the AI Collective, so not sure if any of y'all know what it is, but we are a non-profit grassroots community uniting about 100,000 pioneers exploring the frontier of AI in major tech hubs worldwide. We have about 100,000 members worldwide. We have 100,000 100 plus global chapters, and in about 30 countries. What it really is a movement of trying to bring everyone in space with AI, trying to unite everybody, because I feel like all of our journeys with AI are different. And what we as a collective are trying to do is just trying to bring everyone on the same page so that the journey towards AI is just not as intimidating. To start with, I'm just going to give you all a little introduction into what this event is really about. So, this is not going to just be a basic RAG workshop. What we've realized that about for 2.5 years, there's been this major AI hype, and a lot of our organizations are moving into adopting AI, and there's so much that's happening. I'm sure AI has flooded all of your LinkedIn profiles and your posts and everywhere. And what we've seen is that there are some great pilots and prototypes that have worked with that seem great and promising, but scaling it has just not worked. In fact, a very interesting study, an MIT report, which was released in August 2025, the Gen AI Divide, State of AI in Business 2025, found that around 95% of enterprise generative AI pilots fail to deliver meaningful business impact. I feel like this metric, 95%, is a huge metric to show us that with all this hype, with all these tutorials of what to do, we're only able to get just as far as the pilot, the prototype. But I feel like scaling it is a whole new chapter, with security, guardrails, hallucinations, and just overall seeing that the RAG system is what you want it to be, which is why we are here presenting a conversation to you. We've got experienced leaders over here on our panel, and we want this to be a free-flowing discussion about what's working in enterprise RAG, what's not working, and just giving y'all an insight into it so that with y'all working towards your RAG, just trying to scale it up or at least understand what the issues are so far. And with that, I'm going to start with introducing the panel. First of all, thank you so much for agreeing to join us and just sharing everything that you all have learned with your experience. We're very glad to have such strong voices on this panel today. Yeah. So with Asif Qamar, that's Asif, he is the CTO of Support Vectors and leads the Support Vectors AI Lab, where he trains professional engineers in production-grade AI. With about 3 decades of teaching experience and mentoring engineers. He's also previously served as the Group Vice President and Chief Analytics Architect at Cornerstone On Demand, where he co-founded and architected the company's large-scale AI ML platform. With a background spanning computer science and theoretical physics, Asif brings a rare systems-level perspective grounded in geometry, scale, reliability, and product. The next one on the panel that I would like to introduce is Chaudhary, who's right here next to me. He is the Senior Director of AI Engineering at Visa. He's a technologist and experienced working in large enterprises and across 4 startups in the Bay Area. Djay is leading an innovations team at Visa with an AI-first approach, solving for greenfield and brownfield projects driven by outcomes. The next one on the panelist is Rajesh Beri. I'd like to introduce him. He's the Senior Director of AI Engineering at Zscaler. He's an experienced technology innovator with a strong track record of building and scaling enterprise AI solutions. Rajesh focuses on translating cutting-edge AI ideas into practical real-world impact for organizations. And finally, we have here, representing Snowflake, Rajhans Samdani. He is a principal engineer at Snowflake. He has worked on search and retrieval, agentic systems, post-training for LLMs, text to SQL, and semantic data modeling at Snowflake. Before joining Snowflake, he led at Neeva, which has now been acquired at Snowflake. He has a PhD from UIUC and a bachelor's from IIT Bombay. Before we start, could we please get a round of applause for our panel members? Just gonna get started with the questions. Okay, so are we ready? Okay. So I guess the first question is going to be that with the introduction, where there are so many teams and organizations stuck in what I'd like to say the pilot purgatory. There has been a lot of attempts at moving from pilot to production, and there have been a lot of struggles. So can each of you take us through it? And I would like to start with you, Djay. Could you tell us what has been your experience of taking RAG from pilot to production at Visa? What are the challenges that you faced? What were your initial expectations? What worked? What didn't work? Give us an insight.
Sure. Thanks, Atisha. So one of the things I would like to get started first is understanding that RAG has many different flavors. And each of the flavors brings a very different set of problem space, solution space, and its bounds to the problem. I mean, there are aspects like graph RAG, agentic RAG. Now we are also moving into the relational architecture for the transformer-based model, in which you want to interface with structured data system like databases and so on. So we are trying to define RAGs, in a more layer of nuanced detail, and each one of them solves very different problems. So one of the first challenges that teams face is defining that what are they trying to attempt to solve, what is the success criteria, and the rubric associated with that, and then layering it on with the systems architecture and going into the the pilot deployments, how we measure what matters, and then piloting it out with the end users to make sure that we have a success criteria very clearly defined. So for me, that's really a good start.
Thanks, Dhananjay, for also telling us that the most important thing still remains is defining what your business scope is, defining the problems and the success criteria. Rajesh, what has been your experience with Zscaler? And again, what was something that was surprising that you found out in your journey from pilot to production?
Great question, Atisha. Honestly, if you talk about pilot, our engineers get very excited. They get to play with state-of-the-art technology, spin things together in 2 to 3 weeks, and make it available for people to see. And when you're showing this demonstration, you will get asked, now you built this, when are you deploying? Can you deploy it next week to production? That's where the reality sets in. When you build a prototype and you go production, there's a night and day difference. Let me ask a question to the audience. How many of you are really doing pilot in RAG systems? Few hands, okay. How many of you are gone live with RAG systems? Just a couple of them, right? So that's the challenging part today. If you try to move a prototype into production, you are really doing a disservice because there are a lot of challenges. There's scalability challenge, there's accuracy of information challenge, and what will eventually happen is people will start losing trust on your system that you don't want to happen, right? So we had similar experience where people are excited, they want to make things go live as soon as possible. But if you don't think through this, you're just setting up for failure.
Thank you so much, Rajesh, for bringing this perspective to us. Rajhans, with your vast experience of working in all kinds of agentic systems and RAG, what has your perspective been as a principal engineer, and what are the struggles that you have faced in trying to scale and take it from pilot to production?
So can you hear me? Oh, okay. I worked on, a search system. So what at Snowflake, what we did was we have rolled out our own search service. You can actually use Snowflake for searching over billions of documents and so on and so forth. And a lot of folks actually used Snowflake to search and then set up their own RAG system. So I've experience with a bunch of enterprises who try to roll this out. And maybe just to complement what these gentlemen have mentioned, right? I think one of the things that people get wrong about RAG is they get excited too much by the G part and forget about the R part. So a lot of people get really excited by, oh, I have this generative model and it should just work. And what do you mean I'm using Claude, or why is it not working very well, right? But I think a lot of the hard part is still search and retrieval. And the search and retrieval technology honestly is not that new. It's been around for whatever 30 something years. It's still tricky to get it right. And I think one of the things I would say is a problem that people should look at is make sure that your search is working correct, your retrieval is right. Even before that, your documents are clean, your chunks are correct, you're using the right chunking schemes and so on and so forth. So a lot of this is just still good old fashioned, like, grunt work on like doing data engineering and evals and ML engineering before you even get to the LLM. And I think a lot of people get too excited by the LLM part, forget about the retrieval part. And that's where a lot of the failures happen. Of course, could you have caught these failures if you had good evals? Perhaps yes. But then, of course, a lot of people don't have good evals. But it's having high quality evals is also important. It's surprising how poor the at least the state of public evals are. Like, for example, if you're building a finance answer chatbot or something, right? A lot of people have really fake questions. Like if you go look at all the data sets on Hugging Face or something, you'll find very simplistic questions, very small data sets, so on and so forth. So of course, when you tested it out on those data set, it was at 90%, whatever answer accuracy. And when you deploy it, it's like 30%. Now what's going on is because you didn't actually measure on the right data. So you have to put in a lot of elbow grease into getting things right. And that's just really the work.
Thank you, Rajhans. You actually just brought a lot of important points. I think the first one is the R part, the importance, right? That I've heard this a lot of times, that retrieval has been forgotten and not been worked at. The other important point that you spoke about was evals, and the benchmarks that we use. So those are very interesting perspectives that we will explore in more detail. Thank you for your perspective. Finally, Asif, what is your perspective as a researcher, and just what is your experience, and what's the advice that you have for all of us for taking it from pilot to
Atisha, I'll
production?
concur with all these gentlemen and just echo their thought. See, in our world, Gen AI looks deceptively easy, especially with code generators. Anyone can build a very, very good demo that almost looks real and ready for production in a matter of a few hours. The libraries for RAG will give you RAG in 3 lines of code. There are many softwares which are RAG in a box. Plug it in. It's almost like you attach the computer to the wall, attach a monitor, and you're done. So it's there. But it's the history of our field. In engineering, there's an old truism that everything takes far longer than you thought. It takes far more effort than you thought. We engineers are rather confident beings. We are sure we can build anything in 2 weeks. But then reality kicks in. And RAG is actually one of the most complex pieces of engineering that I can imagine. Lots of moving parts. But the truism goes that in engineering, big projects, they always take far longer than you think. But when they do succeed, they have far larger impact than you imagined. So when you look at places which actually succeed with their RAG, the impact that they have is monumental. Many examples, Perplexity, who would have thought that you could go and do something in the search space with giants like Google and Bing present? And yet Perplexity came, and Before we knew it, all of us were using it. And then a ChatGPT followed. It became, all of these are RAG systems. But at the same time, opposite is also true, to the point that people trivialize RAG. And so what happened, it reminds me of a quote from Tolstoy. He started his book, Anna Karenina, by saying, all happy families are alike. Each unhappy family is unhappy in its own unique way. So when you look at the RAG problems that different companies are facing, and I sit there and a lot of people companies approach and take advice, if I'm looking for the common denominator, in all the cases, they have different failure modes. They failed because they forgot to consider this. They failed because they forgot to consider something else. But the one common denominator with all of them is they all vastly underestimated the complexity of a RAG system. And I do agree with Ansraj that Rajhans, that RAG is not about getting the latest and greatest generator, the language model. Actually, in a RAG system, the generator matters, but not as much as you think. Most of it are in two places. One is in the retrieval part, the retrieval architecture, which has many years of evolution, and it has to do with the architecture of RAG itself. Have you considered properly? Is it iterative, or is it just a single pass forward pipeline, and so forth? So we'll talk about that.
Thank you, Asif, and thank you to all of you all to just giving us a perspective into the first fact that RAG is not that easy. It's just not a plug and play. I feel like all of you all have told that to us. And what I hear from all of you all is, again, it's about defining your system, right? So then it probably comes about defining what your system's supposed to do, and I think that brings me on to how do you correctly define it? And probably what does success mean? What does failure mean? And then the next question, probably, or a follow up, would be that how are you at your organization tracking improvements over time? And like Rajhans mentioned, was the evals. Could you all take us into the technical evals that y'all are using? How are they working for y'all? And then also on the business side of it, because again, we need to make this work, right? So I'm going to start with this one with you, Rajesh. Can you tell us what's been your experience at Zscaler? In how do you track improvement over time?
Right. So, again, very great question. So, our primary single metrics that we start with is always adoption. Anytime you introduce a new system, you'll find higher adoption, which is apparent because people want to try some things. And as people adopt, you will start hearing questions coming from your business users. It's too slow. We'll hear, like, this is giving an answer that I was not expecting this way. And one of my favorite one is, I don't trust this. Now, it's important to understand these things because these things will either kill your system or make it successful. So it should always be a thoughtful process before you start your project. What are your success criteria? How would you define success, right? And never go verbally. You have to use tools and systems and platform to measure actual output, right? Adoption, you can easily measure, but the quality of response is very important. You have to use eval on a regular basis, not before you go live, even after going live, because the there could be a drift happening in your responses as the model changes, as the prompt changes, the quality of that also changes. So it's very important to address that early on. It's very important, last piece I'll say is very important to have your RAG solution giving you right response. If it gives a false response, losers will trust you. And it's better not to have a RAG if it's giving false information rather than having a RAG system. So.
Thanks, Rajesh, for just taking us into adoption. And I totally agree. I would be one of those people saying that this is too slow and I don't trust it. So yeah, that's probably the end consumer. Rajhans, you already took us a little bit into evals and spoke about, the false effect that benchmarks give, and that was a very interesting take. Could you take us a little more into it? And what's been your experience? How have you been testing that your RAG system works? Just take us into the process that's happening at Snowflake.
I mean, of course, there's There are a couple of different components to it. There's, of course, defining the data set, making sure that you actually indeed do have the data set that measures what you want. Uh, sometimes even to get a decent system out, you don't need that many data points. Even if you have 100, 200, few hundred queries, it's actually pretty reasonable as a starting point. But it is important for each of those queries to accurately reflect the complexity of the task at hand. So I do suggest spending the time to actually get up. So let me give you an example. If you expect a lot of your documents to be long form, but you get lazy in creating data sets and you just scrape something from the internet or download something from the internet and all of your documents are 1 or 2 pages, you're going to be unpleasantly surprised when it actually is deployed, right? So actually having long form documents as part of your eval sets is important. If you expect your information to be non-localized, i.e. have the answer be present in multiple places in the documents, then it's actually important to have that eval set represent these cases as opposed to a single point answer, right? So that's one part of the puzzle. The other part of the puzzle is getting some of your evaluation metrics right. And therein, again, you probably want to track in the whole funnel, because at the end of the day, at least, Djay mentioned like various versions of RAG, and depending on the versions of the RAG, you probably want to set up different forms of eval. But if it's some sort of a simple funnel of RAG, which is like retrieval followed by generation, you probably want to measure every step of that funnel, right? Which is how many chunks that I have actually contain the answer. What is my recall at 100? What is my recall at 10? Recall at 5? And then, in terms of the final generation answer, what is my accuracy and so on. So it's actually important to measure your entire funnel and also have the right data set. I won't take too much of the time, but I want to let Asif also answer this question.
We also have Djay left.
And DJ also,
Go ahead.
Okay, so thank you, Rajhans, for just telling us about like the importance of evals and how they need to be representative of what your problem is supposed to be and to not get lazy with it, which is something we engineers need to hear, to not be lazy. So Djay, what's been your experience at Visa, and take us into what's the eval and how you're tracking it all?
Thank you. Asif is a authoritative answer, so I think it's great to have him the last word. So I'll defer to him after this. So one aspect of again RAG that I mentioned, different types of RAG systems, and the most common thing that we expect is unstructured data set. In which you have documents, you have different media types, audio, video, images, text, and so on. And trying to get metrics out of that kind of system is a very different than when you have a RAG system which is coupled with, let's say, enterprise data, like enterprise data sets, or when you're into different verticals which are controlled. For example, imagine having a RAG system in a law firm, a legal firm, or in fintech or healthcare, and getting a degree of accuracy that you expect is completely different. You cannot have, let's say, a fintech company with is backed by enterprise data sets to come up with the wrong answer. Because as we know, the G part, the generative part, is all about the LLMs, which is non-deterministic. So how do we put in the guardrails in place so that we can converge to a deterministic answer following some rules? And it never, ever hallucinates. So that is an art part of implementing a RAG system. Making sure that we take aspect that Rajhans mentioned, recall, precision, F1 score, and so on. And that becomes the center of the conversation to make sure that we can measure what really matters and make sure that we capture all the data sets during the rollout, from pilots, capture the meaningful conversations, the input prompts, and looking at the responses to make sure those metrics are aligning with the expectations of the specific vertical that we're trying to solve.
Thank you, Dhananjay, for giving us your perspective. And Asif, now we will take this to you. Again, what are the metrics that you would tell us to use? Are they as daunting as we all think they are? And yeah, give us your perspective.
Thank you, Atisha. So the gentleman here have touched upon most of the points, but I'll put it together with an analogy. Well, of course, daunting is it's not daunting. The definition of hard is if you know how to do it, it's easy. If you don't yet know it, it looks hard. So just know, and then it becomes easy. See, I give the analogy of a car. First is the domain expertise. If you build a car and you build it for an audience, for a domain, you don't give a teenager, a minivan, he'll be deeply disappointed, right? And the converse is true. In RAG systems also, you have to ask, which data are you dealing with? Are you dealing with scientific research papers that have graphs, figures, equations, all in the same page along with text? To handle that is very different. To do a RAG over structured data, relational data, is a different kettle of fish. And so whether you're doing RAG on, again, like it was mentioned, a short form document, small Twitter messages, or on in-depth reports is different. Data that is mostly as tables in PDFs, you have to handle differently. So domain specificity and being sensitive to that, I would say, is most important. And metrics arise from that. So the metrics you can classify, again, using the car analogy, in three ways. From the sales perspective, a salesman will say that the measure of a car is how many units it sold, right? What's the adoption rate for your RAG application within whatever user base you meant it for? Do they trust it? What do they say about it? From an enthusiast perspective, if you give a teenager a sports car, he would say, okay, this is the RPM, and this is the number of seconds it takes to reach 60 miles an hour, 100 miles an hour, and so forth. So for a RAG system, it's like, how do you look functionally at it? And how do you quantify that the entire system as a black box is working well? So for that, you look at faithfulness, you look at the hallucination rates, how often it misses crucial facts, and so forth. But just like a car is a complex piece of machinery, you don't build it just by looking at it as a black box. RAG is a complex machinery. There are many parts, guardrails. It has its own metrics. How often do mischievous content leak through, unacceptable content leak through, at the query side or on the response side, right? It needs evaluation metrics for guardrails. You have semantic cache, which means that if a question has been asked and it is just asked again in different words, are you dipping into the semantic cache, most often getting a hit, or are you having false hits and things like that? So there are metrics for that, the precision, recall, and hit rate, and all sorts of things. Then for the retrieval part itself, there are well-established metrics in the search industry. You have the normalized discounted cumulative gain, it's a big word, NDCG. Then you have mean average precision, precision recall curve, simple things like hit rate, and so on and so forth. It's a very rich set of metrics. But how do you use those metrics? You have to sit first and create your evals, create the benchmark data set. And I often advise that the team creating the benchmark data set should be different from the team of engineers. Because if the engineers can see the benchmark data set, they will engineer the product to it. Right? So keep it separate. It's a basic rule in machine learning. You hide the test data. Do that. Likewise, when it comes to the generator part of it, you need to test it by asking the groundedness question. Has it answered the question based on the facts that are there in the retrieval, the search results? Or has it used its parametric memory? Or worse still, has it just simply hallucinated? You need to create a bipartite graph between the facts in the response and the search results, and be able to map the two and see, is the result complete, or do I need to do a few more cycles, exploratory search approach to improve the RAG experience? It is there. Then the other aspect is the global versus point queries. It is much easier to create point query RAG systems that answer specific factual questions. You break up your data into chunks, and chunks, for example, I take this example of a story by Dostoevsky, Crime and Punishment. The story goes roughly as there's a young fellow who, in some notion that he has, he decides that it's perfectly okay to go kill an old woman. And he does that. And then suffering comes because he feels the sorrow of it. He feels guilty about what he has done. It's terrible. He suffers through it for the long, long time. And then finally, he hands himself over to the police. When he does, he's sent to Siberia as a punishment. So if you look at it from a point query perspective, as a RAG, if you ask something which has just chunks of data, and you ask, what was the punishment? What was the crime is easy. What was the punishment? It would always say, well, he has been sent to Siberia. right? But the punishment, that was actually the release from punishment. The punishment was the suffering the person went through, having committed the heinous act. But you cannot, it's not that easy to build a RAG system that can give you that answer. And that's important because that needs a global understanding of that. And that is where the value of things like GraphRag come in, which do abstractive summarization of the facts. Also, it is important to seed your RAG system with questions you know there is no answer in your data set. You need to have a system that can honestly say, I don't know. I often ask this people, engineers, has your RAG system ever said, I don't know? Right? Yeah, yeah. And the honest truth is almost nobody is able to create such systems. See, we are engineers. If you ask any engineer, can you unify quantum field theory with the theory of relativity, right? They will say, well, give me 2 weeks. I'll write the code and it'll be done, right? We are confident beings. And likewise, the LLMs that we create and the systems we create are equally confident beings. It need not be possible, but it will answer anyway. Right? Which is unacceptable in an enterprise environment. And so one of the hardest things in your benchmark should be, when does your system say, I don't know? Right? Anyway, a few points.
Thank you so much for giving us a detailed insight into all of the evaluations. I guess now once we've started defining our metrics and all, let's get to the meaty part of it, the architecture, the system, Tell us what's working in your system, how have you designed systems in your organization, and what worked, what didn't work, was there something, and like what were additions that you had, just some insights for taking us into the architecture of it. DJ, we will start with you.
Certainly. Thanks, Atisha. So over here, again, I like to follow the KISS principle, keep it simple, stupid. So if a system works, which is as simple as possible, go for it. Till the time you can vet and validate and show that it's actually giving the results. And which can be even a naive RAG system, right? Which is just, the retriever, and generator connected together, and we're done. Okay. So I think it really depends on the expectations of the end users. If it's giving the answers, then you don't have to over-engineer it. So you don't have to go down the rabbit hole of finding out and over-engineering the complexity by advanced techniques. Okay. So it's all about knowing the problem set and knowing the expectations of the end users. Okay. What we have seen in action is such a naive system rarely ever works. So it does need some advanced strategies. At the very basic, I think you will need to implement some kind of a hybrid search in which you have a dense search along with the sparse search as well, which is popularly called as a keyword search, coupled with a re-ranker. And then we can go into some more advanced techniques, like you can go into domain specificity of the embedding models, going to the dimensionality of the embeddings and so on. But those are advanced techniques. And it really, I think, as I mentioned, is try to make iterative steps towards bolting on to the architectures while keeping an eye on the outcomes with the measurements. If you cannot measure, you cannot improve. So keep that in mind and then iterate and build.
Thanks for iterating on the fact about starting simple and then again in reinstating measurement. Rajesh, has your experience been similar with the architecture? What is it? Can you give us an insight into the RAG architecture and Zscaler?
Sure, I'll give you my perspective. Before getting into RAG journey, I was very optimistic. Take the data from everywhere, put it into vector store, put in LLM, you have solved the problem. But the reality was totally different. In enterprise, if you see, your data is distributed everywhere. You have enterprise applications with different types of data. You have documents, you have tables, you have images, you have structured data. Even within structured data, you'll find unstructured content like notes, sales notes, renewal notes, and so on. So there's vast type of data that is existing in your ecosystem. Our biggest challenge was, how do we get all this information into your vector store in the right way, right? So there's nothing called as one size fits all. If you're taking structured document, there's a different way. If you're taking unstructured document, it's a different way to process it. Our biggest challenge was creating this ingestion pipeline that is foolproof and works every time. Maybe you'll make it work every time, but what about data changes every day? User keeps on making changes to data. Your data gets old. Like if a new version comes out, your old version is outdated. How do you keep that data? It's an important thing to consider, and a lot of time gets spent over there. RAG architecture is really simple. But what is complicated is the messy data that you have in your enterprise and building that pipeline that works like accurately every time.
Thank you for reminding us again that data is our biggest problem, Rajesh. Rajhans, could you take us into the architecture that's at Snowflake, and again, tell us about some probably learnings that you've had throughout the process and all of the iterative learnings that you've had in your journey.
Okay, I'm going to start the part here. So data ingestion, I completely agree, right? But maybe question for you, DJ, right? Is this, you said start simple. Now the question is define simple. So I'll give you three options. Option one, you have your chunking, whatever, PDF parsing, blah, blah, blah parsing, chunk the data, do retrieval, do re-ranker, do all of this, right? Option two, I take your PDFs, you store everything as images. It's possible, right? You can take PDFs, you can store PDF screenshots of every page. No need to chunk, but you need multimodal models,
Correct.
right? Option three, I put everything as some sort of rough PDFs, right? But no chunking, no retrieval. I give it all to Claude Code. It uses grep, does all sorts of weird things, right? But it has a 200K context window. It's able to agentically go through it, right?
Yeah.
Now, these are three different options, relatively all increasing in the advanced capabilities of LLMs. I would argue different in simplicity. The first option is not necessarily simple because you have to maintain 5 different components of your pipeline, right? So now which one do you pick, right?
Excellent question. And here's my attempt.
And then sorry, Atisha, I'm just gonna
No,
take it a little bit unscripted.
This is a great exercise. This is perfect for a fireside chat. So the third strategy, which is, just give it to the Claude, is great if I have a really thick, big, fat wallet. Mm-hmm. If my company can afford to go to the large LLMs, okay, and they can guarantee things like privacy, data security, and all other good things needed for enterprises, and they can afford to pay those bills to the hyperscalers, then, to me, that is really the simplest option. Yeah. Okay. So it really depends how do you define simple. Okay. The second option, we're talking about just use a PDF, take the image. Okay. This will be great if you have a really good visual language model, the Lava based, etc., in which you have a multimodal model which can understand structured data sets like tables, images embedded. The images have semantic meaning of their own, which is doing things like entity extraction, knowing what are the different components of the image, the scene, the setting, what are the different objects, and so on and so forth, and decipher the intent of the image itself, right? So second option is really good when you have a really good visual language model that you can control, and it can infer all aspects of the page. That page can include things like handwriting, regular text, and all different models of data, structured data like tables and so on, right? So here there's over-reliance on a visual model to extract meaning and processing out of the whole thing. Okay, such a model is in progress. I mean, the frontier models are really good at it, but trying to bring this in-house is a bit of a challenge because there aren't enough open source models able to compete with the frontier models on that.
I mean, I can give you some examples, but okay,
yeah. But
okay.
Again, this is a race going on, right? I mean, you can certainly have that gap to narrow down, but this is where you may have some challenges. I'm assuming that you will be hosting your own the language model. You will have capabilities to scale it out at large scale. You'll have enough GPUs and so on and so forth, right? So that's the second option. To me, that's a little bit of a, possibly simple. Again, defining simple, what simple is. And the first one is the regular one, which we all know how to do the ingestion pipeline and do your own thing. To me,
I
that's
think
more complex.
so my take, I guess the thing that I'm poking at, and I'm poking at it with like maybe 80% confidence, not like, but it's a strong opinion held for the sake of performance for this audience, let's say,
Yeah.
is I think there is, we formed some level of comfort with the old school retrieval, whatever pipeline, and then we kind of tend to use that, right? But I think we often underestimate how powerful some of the modern language models are. Last year, we published a blog post that actually compared on, somewhat challenging engineering manuals, SEC docs kind of data sets, where we actually compared what happens if you take some doc or PDFs, parse it, and the parsing is going to be somewhat noisy, right? Because you lose some information, then chunk it and then go through your usual thing, versus now you take document screenshots.
Correct.
Do document screenshot embedding. There is actually a very good Alibaba embedding model that is on document screenshot. Use only the document screenshot embedding for retrieval, feed it into Qwen, which is a VLM, right? And we found that the latter actually outperforms surprisingly the former. And not just on questions that, kind of require chart reasoning, but even questions that are on tables or like questions that require, actually even like point, to your point, point-based answers, right? So we were very surprised by this. And now, of course, this required us to use a piece of technology that we are like, oh, well, we're not quite sure why is this working very well. But the point really is that the frontier is being pushed.
Yeah.
And, whether we like it or not, the definition of simple is going to get changed. Because these VLMs are going to become really powerful, for example. And the next paradigm being, Claude Code with grep becomes really, really powerful. Now it's a function of, you mentioned like, how many dollars do you have? But it's also a function of like, at Snowflake, we say this implicitly in our team, which is, the most important thing for a lot of our customers is accuracy. Second is latency. Third is price, at least on various high quality use cases. And if the accuracy, starts looking really good on, for example, on some of the global questions task, right? Then suddenly the option of having a LLM read entire docs becomes very, sort of lucrative, right? So I think I don't have a clear answer to the group, but what I have is a food for thought, which is I think, the definition of simple is different. Keep your eyes and ears open. You might be building a pipeline which is a 2-year-old, and 2 year is like 20 years in LLM land. And so just try new things, or keep, and then see what is being done and then try out new models. And, you might just be surprised.
Very well said.
Thank you, Rajhans, for just stirring this conversation. That was a fun plot twist I didn't expect. Asif, let me ask you, what do you think about what Rajhans asked,
Yes.
something on it, and just share about like the RAG system architectures that you worked with?
Actually, this is a very insightful discussion. So I suppose to add to it, I'll just step back and put a historic context. I will use cockroach. and I'll use the concept of tournament. No, the Kafka. He's referring to Kafka's metamorphosis. Franz Kafka woke up in the morning and he found he has metamorphosed into a giant cockroach. So, well, anyway, Galileo made an interesting point. He said that architecture is never scale independent. So, for insects, if you observe them carefully, they have exoskeleton, isn't it? Which is why if you are sipping soup and you find it crunchy, you get worried. On the other hand, human beings have endoskeleton. And the reason for that is, at our scale, endoskeleton makes sense. At the scale of an insect, an exoskeleton makes sense, which is why insects have outside skeletons, exoskeletons, hard shells, right? If there is one lesson of engineering that I've learned in my life, it is this. Don't forget what Galileo said. Unfortunately, very few people know. So to the point, like very nicely, this question was posed, which of the two paths you would take? And the answer often is scale dependent. See, suppose I'm just sitting there with a few documents. I want answers. I have only 4 documents or 10 documents. Do I start with guardrails, chunking, semantic cache, then bring in graph RAG and everything. Maybe it's an overkill. Let me just feed it into an LLM and see whether it suffices or not. Right? Is that the right scale for the? So that scale requires that solution. On the other hand, if you, as you scale up, many pathways open up, and it is always wise not to have a tunnel vision, but what I call running tournaments. And that is what science is about. See, this AI field is very experimental. It is almost like you have to climb a mountain, but there are no roads. So we're all trying to figure out which are the paths to take. And so keep your mind open, run a tournament, try different experiments, and see which of them is getting you better results. Now, to this point, people often make that LLMs are becoming huge. They have huge context window. That is true. Nevertheless, the key limitation is the attention. If you, those of you who are technical, and forgive me for the rest of you, one of the problems with attention is no matter what you do, it's a quadratic equation. Means a cost, compute cost at inference time blows up by the square of number of tokens. And of course, likewise, you see the effect on your bill and so on and so forth. But whether on-premise or through API, you can't get around the quadratic cost. It leads to all sorts of effects, latencies. Yes, you can pass in the entire Encyclopedia Britannica and ask a simple question. But is that the best way to ask that question? Is that latency acceptable? Is the cost acceptable? Right? The other is there are other limitations with LLM, like sort of the bookmark effect. It tends to remember things in the beginning and end far better and synthesize that in the answer than it does things that are in the middle. There used to be a more severe problem lost in the middle, which is mostly mitigated, but the bookends issue is broadly still there. Now, architecture and what scale you do, whether you use, for example, to this point, OCR technology is rapidly moving. In fact, one of the DeepSeek's recent very good paper was a DeepSeek OCR, which was ironical because it was the inverse of it. What it said is, given a page which has figures, you would think we can do OCR. But what DeepSeek was doing is, it was saying, even if you get text, convert it into an image, and then pass it through the transformer layers. And they got amazing success with that. So we are in a very fluid, very experimental space. Do not have tunnel vision. Run many tournaments, run a tournament of many experiments, see which one works for your domain-specific situation, and build an architecture around that, is how I would put it.
Thank you so much, Asif. I guess I'm just going to follow up on something that Rajesh started, was the importance of data, and again, maybe not a very exciting question, but I do want to dig deeper into it, just talk about everything to do with data, the pipeline, the ingestion, all the different kinds of issues. And if this question is particularly, so y'all could give the audience an insight into just how messy it gets and, how they could navigate it, So let's start with you, Rajesh.
Sure. So the approach we took is like we tried to categorize data into 3 buckets. One, you call it as unstructured data, like those are documents and notes and Google Sheets and all those type of things, not sheets basically. The second set of data type is structured data that sits in your data lake, which is a massive amount of data. And the third data category we created is called as relationship data. This is your graph data that stores entity and relationship, right? And as you process your data through pipeline, you want to use the right technology or right chunking strategy for each type of thing, right? Which is very important. Again, as I mentioned before, there's no concept of one size fits all. Everything is custom depending on what you're ingesting. The chunking strategy could be different. The way you're processing your information in graph is different. And the way you're treating structured data is different. Now, when a user is asking a question, typically you want to get data from multiple data points, right? You want data coming from your semantic search, which is your vector store. You want data coming from graph, which gives more abstractic information present to the user, as well as there could be instance where you want data from structured content, right? So if you don't stitch this well together, yes, you'll still get an answer, but will that answer be relevant to the user? No, right? So it's very important to ingest your data well, use the right chunking strategy, use the right methodology like text to SQL, whatever you use, and even graph traversal, do the right things. If you do those things right, I'm confident your users will get the right answer and the trust will be maintained.
Thanks, Rajesh, for talking about the importance of just, I think, classifying data and then understanding how to pick them and get them. TJ, then to lead the question to you again, if you could just give us insights into or any anecdotes that you have about just how frustrating data has been and how y'all have navigated that challenge.
Sure. So similar themes as Rajesh. Um, I think it always we have to make sure that the system is not garbage in, garbage out. So there's a lot of effort that has to go in during data prep, data cleansing, data transformation phase itself before it hits any parts of the Gen AI based system. So I would not like to discount that part. That is hard work, grunt work, and as engineers, it's not in our nature to do that grunt work. We try to tend to skip it off. Okay. But that is where there's a bulk of where we have to really get the data ready for consumption for making an AI system work, and that should not be underestimated. And I think this is where engineers typically do fall short. And that is when the journey really starts, in my opinion. After that is where as Rajesh also hinted, doing preparation for unstructured data set, which is very different, in which you have to add domain specificity. Like if you're a legal, fintech, law firm, etc., you have to make sure that those acronyms, are well understood by the system, their intents and purposes. You have to make sure that you fine-tune possibly an embedding model, which gives you that domain specificity, so your accuracy and precision really goes high, rather than using a general purpose embedding model that you can download from Hugging Face or from any of the popular frontier providers as well. So that to me is extremely important, to get domain specificity on your unstructured data set, make it relevant to the solution space that you're trying to solve. And then on the structured data sets, it is important to experiment a little bit. There are latest techniques being coming out recently. There are aspects like putting a semantic data model on top of your databases to make sure that ontologies are created out of this, in which you have a domain-specific ontology about how the different aspects map into the system, and then use that to guide and create the advanced RAG system, so that you can have maybe this text to SQL generation, which is very specific to what a Gen BI solution may look like, which is where the world is kind of converging to, doing conversation analytics, customizable NLP-based dashboards, and so on and so forth. So enterprise BI and Gen BI, I'm sure Rajhans may be able to share more of his thoughts on this as well, because I'm sure Snowflake is doing something on this space as well.
And Rajhans, can you take us forward with it and also take us a little into the chunking processes? Because I'm sure that's something that the audience would like to know. But of course, just share what's the process been with data, just get real about it.
Yeah. So I think both of these folks have covered some aspects really well. So I'll try not to be redundant. I think there is one aspect which is also there's like, if you go further upstream, right? And let's say you're pulling data from Google Drive, you're pulling from OneDrive, you're pulling from Confluence, and much of these things. Maintaining these integrations is actually a non-trivial amount of work, right? Google Drive gives you one admin token. You can use that to scrape. OneDrive is a different process. Every one of them has a different SSO process, and so on and so forth, right? Or you do some sort of cross auth and things like that. So I think there's a lot of this grunt engineering work that's actually very important. I think maybe 60% or maybe 80% of the battle is really just getting the data. If you are actually dealing with indeed multiple sources, if you happen to have all the data in S3 buckets, great, right? But most of, at least in many enterprise scenarios, you don't, especially if you're selling a product, right? Like, what is the biggest advantage of Glean? Like, I think the thing that they have is like having all of these integrations and pulling the data from 50 different sources, which is really their moat, right? So I think that I think is a lot of work. Don't underestimate it. Start simple. Start with 1 or 2 connectors. If at all you're pulling data from various different sources, and then of course there is all the other downstream processes that I will not repeat. One in terms of, I guess your second question you asked around was around the chunking process, right? So we depends on, again, the data size. I think as like Asif mentioned, and the size of the documents. So if I would, let's say, if you were to focus on longish docs, which is actually fairly common, if you're dealing with lots of sales contracts and all sorts of stuff, right, which tend to become really long. There are various different strategies. People start often with the simplest thing, which is a fixed size chunking. Of course, that doesn't work very well, but it's simplest to implement. Then you can do what is called hierarchical chunking, which is, you store in all the section headers all the way. So you have full context of where the chunk appears in the doc. So if something is in like top level section, second level section, third level section, you append all of these things. What we found works better, and we created we wrote a blog post on a fairly non-trivial data that we created over SEC PDFs last year. What we found works better is if you take chunks, which are, let's say, even if you take local chunks, you use a generative model to actually create some sort of a global context associated with the doc, and you take that global context and then you stick it on top of that chunk. Because to give you an example, right, let's say if I have 20 years worth of SEC PDFs, right, and now your question is, what was Netflix performance or risk factors from the year 2019 to 2022, right? Now, what do you want? You want SEC 10Ks, not 10Qs. For example, let's say if you're looking at yearly ones, you want Netflix ones, and you want 2019, 2020, 2021, 2022, right? In order for this to happen, you need to have, now if you only take a chunk from the doc that doesn't have the global year information, you're done, right? Like there's no way that chunk is going to be retrieved. And maybe you got lucky and that chunk will get retrieved, but otherwise it may not get retrieved. So you need to somehow capture the global context and append that to that chunk, right? So this technique works pretty well. Now, of course, there might be some other techniques as well. Anthropic had this contextual chunking thing where they were calling an LLM per chunk to generate that global context. Now that is pretty expensive, right? So we found the per doc level global context appended seems to work pretty well. But pay attention to your chunking. Pay attention to even a chunk level metric, I would say, which is how many of the global answers or gold answers I'm looking for appear in any one of the chunks that I have. Sometimes the answer might be spread across multiple different chunks, or you might be breaking the chunk across the right boundary where the answer then just becomes hard to discover, right? So paying attention to chunking, I think, is also important, and there are various different strategies. Don't get satisfied with like fixed size chunking.
Just one thing I want to add, as he alluded to earlier, like getting data is important aspect, but please don't forget security aspect of it. That's the most challenging part you'll have to go through as you're taking data from Google Drive or SharePoint or whatever. You have to get permission aware information also, so that you're displaying right content to the right person. Very important.
I will add one more. I think security needs some more discussion as well. So when we go to source systems, okay, we tend to flatten out the security hierarchy. I mean, that's the most naive way of doing it. So in short, in the enterprise world, imagine going to your HR system like Workday, etc., and getting all the information, like including salary information. You don't want to ever show that to each and everyone, right? So you have to ensure that if you're putting a RAG system in the context of an enterprise, you have to obey and respect the authorization rules, which works very differently the moment you transform that into a vector space. Okay, you'll have to put in the metadata associated with the right your vectors to make sure that when the retrieval is done, you are enforcing the authorization constructs and not excluding the security information.
Thanks, Dhananjay and Rajesh, for just quickly jumping in and reminding us that security is important. And thanks, Rajhans, for just speaking about, I think, hierarchical chunking and just contextual chunking. Asif, tell us what's left for data, if there's anything else. And like, Are there any other chunking strategies?
Yes. See, when we talk of data, data comes in so many forms. Everything is called data. You can have time series data, you can have textual data, you can have image data, video data, thermal data, right? Audio data. And so each needs its own special treatment, and there are problems with each one of them. Going back to Tolstoy's quote, each unhappy family is unhappy in its own unique way. So, but I'll focus, because we were talking about chunking, I'd like to dwell on it with a children's joke. What is worse than finding a worm in an apple? Finding half a worm. So the problem that happens is, see, let's take vector embedding. What is our notion? One piece of text that means something, has semantic content. We make it a point in a vector space and in a typical unit hypersphere, right? But is it really a one unit of thought semantically, or is it half a worm? The language comes infested with polysemy, homonyms, and anamorphisms. So when it says it, and the chunk starts with it, you have lost it already. What was it referring to? What was the outer context, right? And in scientific documents, we see it all the time, as can be seen in equation 4.6. 4.6 was 15 pages ago. Right. So these are the real issues that you have. So to address it, there are a whole bag of tricks. You can look at data hierarchically, top down, break it up. Then you can recontextualize data. Say, let's reattach a piece of the worm back into it. You take a chunk and you say, okay, how do we recontextualize? There are ways to do that using an LLM, using late interaction, and so on and so forth. We should do that. Right? Those are aspects to it. And then you should also, to the point Raj made, sometimes it helps that there is a broader persistent context. It's like a background radiation that is there. What you should do is take a global abstractive summarization, perhaps the graph RAG or something, and make it a part of each of your system prompts that go in, that every single chunk is contextualized with respect to that. It could be, for example, the background summary of a chapter. It could be, or for the whole domain or for a topic and so forth, and you could pass it first. So chunking itself, even something as simple as a textual chunking, which we think, oh, we're done with chunking, let's move on. But actually, if you don't do it carefully, you have already lost it. The other aspect of data I want to point out is data, text as it is written is free form. It is interleaved with thoughts. There are many thoughts in there. And so when you think of semantic embedding, now you're saying not one thought becomes one point, but I'm not able to disentangle the thoughts. So it again brings up a lesser appreciated point. Nothing prevents you from rewriting that text, right? Creating derivative text out of it, in which the thoughts are disentangled. They're papers. People call it extracting factoids and so on and so forth. Disentangle the thoughts, do all of this. But to the main point that Rajesh and Dhananjay are making, data is central. If you don't pay attention to data, you can go bring the most expensive models, large language models, the most expensive embedders. It won't help you. The other thing is your embedders also should be data centric. See, when you download an embedded, let's say you go to the MTab leaderboard and it says that blah, blah, blah model today is #1. We tend to download that and we say, okay, we are done. No, you're not done. You have to. And there's an emerging field called information geometry. When we look at the whole process, what we realize is, think of it like that. That embedded has been trained on world data. So it is putting points everywhere. So your domain, let's say is finance, is localized to one part of the globe. In that, if you think of the sphere as a globe, it becomes like Australia, right? Because your company, your enterprise doesn't deal with other general knowledge, the rest of the sphere is empty. So imagine buying a globe in which the only continent represented is Australia. You say, well, what about the rest of the space? Why wasn't it better utilized for accuracy, for precision of our system? So then you fine tune the models. It's very important to do that in a data sensitive manner so that your RAG system improves. So again, speaking to data. Yeah.
Thanks, Asif, for that. I guess the next question is going to be something that Rajhans pointed out. I'm not going to lie, both of your names are very similar, and I feel a little tongue twister, Rajesh, Rajhans. But coming back to the fact that you said that people forget the R, in RAG, and retrieval science has been around for a while, right? So I think the question to everyone over here is just that how are you all really making your retrieval systems better? Because I feel like our RAG system is only as good as the meaning we extract out of it, So if you could be the first one to take us through the entire retrieval aspect of the architecture.
Sure. So I think, well, one is, first of all, we need to also think about as I mentioned, alluded to in one of my comments earlier, is if you are doing a lot more agentic things and you're allowed to do this, the kind of retrieval or importance you put to retrieval might actually be lower. Which is, I'm contradicting myself when I said first thing, the R part is important, right? Is if I'm allowing a really powerful model to just use, even grep, right? Which is like the most vanilla basic form of retrieval. But actually, just a quick code. How many people here have tried Claude Code? Have you tried Claude Code not for coding, but for just information retrieval on some data sets? How did it work? Did it work well? Not too well? Really good, right? And it's only using grep. It's not using, semantic search, right? So there is something to be said about, this experience, but let's just put that aside for a moment, right? Uh, I do think that the retrieval part, as I think as DJ mentioned, having hybrid search is really important. Of course, depends on the task. If you are really expecting long form queries, let's say your task is customer support email answering, then maybe you can skip the keyword part. Many keywords are not going to match. That's fine. But in most scenarios, you probably need a hybrid search, right? Then second part is getting the embedding model right, like you're mentioning, right? Getting the domain specific embedding model. In fact, if you go to one rookie mistake people make when they look at the MTab leaderboard is they look at the combined score. The combined score is actually not that useful because retrieval is only one of the columns. Everything else is like semantic similarity. I don't care. Some sort of negation score. I don't care. Right. So you really probably want to focus more on the retrieval score part. But coming back to this, right, you probably want to evaluate a couple of different embedding models, right? And then you have the hybrid model, and then then there's, of course, we went into chunking parts, and then it's about setting up the evals. Now again, eval is also interesting because sometimes the traditional IR metrics may or may not make sense in this context. To give you an example, if you look at NDCG, right? NDCG is the sort of the darling IR metric. And what NDCG really does for the benefit of the audience is like, let's say if you produce some documents from rank 1 to 10, then if you have golden documents or the good documents appear at higher rank, then you tend to give it better score than the documents that appear in the lower rank. And the discount that you apply on the quality of the documents is roughly sometimes is like 1 over log of the rank that they appear, right? So if something appears at log rank 10, then you give it only 1 over log, 10 plus 1, whatever, 11 score, right? But now NDCG is less important in RAG because what happens is I'm actually just going to put these awks all together and then and maybe just append them and then ask the model to generate. So it doesn't really matter if the good document appears at rank 8 versus rank 2. In fact, there was a lost in the middle problem that you alluded to, right? So actually it's better for a good document to appear at rank 10 than to appear at rank 5, right? So a lot of all the other retrieval metrics or some of the retrieval metrics may not make sense. You probably want to focus more on recall. So there are some nuances around getting the retrieval to work well with RAG systems. Maybe I'll stop here, but maybe and other folks can comment and then we can come back to this. I think this is a meaty topic. It can probably take us 30 minutes just to go through this. So I'll just stop.
Rajesh, what are your insights on any of this? And I think there's a lot of mention on, I think, fine-tuning embedding models. Has that something that you all have also explored at Zscaler?
We have not explored fine-tuning embedders yet. We are looking into it. But coming to retrieval aspect of it, right? And again, we try to use multiple retrievals Definitely you have semantic retrieval, you have relational data retrieval, you have graph retrieval. Again, depending on use case, you'll take a lot of data from multiple systems and then apply re-ranking. You might also do get diversity of information from everywhere just to you're getting broader information available, right? See, the most important part is like if an answer is given and it's not correct, the first thing engineer will start complaining the model is not doing its job. No one looks into retrieval aspect. Is it really fetching the information? If the information is not fetched, whatever model you put, it will never give you the right information, right? So retrieval is, again, as chunking is important, retrieval is also important because you need the right data in order for LLM to display it correctly, right? So we are really focusing on like getting data from various sources, consolidating, and then giving the right answers to give diversity of information and completeness of information.
TJ, moving the same question to you and also to you, have you all been fine-tuning your embedding models yet? What's been your experience? And in general, just retrieval at your organization.
Certainly. So at its heart, I think as the panel has mentioned, retrieval is at its core, and that should always be the focus. So one of the things I recommend to my team is, forget the G part, the generative part. I mean, you can truly, test your retrieval without the G, okay, in which make it run through your embeddings, get through the ingestion, put it into a simple vector store, and just run some queries against it. Okay, if that is able to answer your questions in a very definitive form, that basically tests your retrieval. I think that should be in my opinion, the right journey to make sure that the whole team understands retriever is a heart of the system before we bolt on the G part with the generative part. And keeping the metrics in mind, recall, precision, I think these become extremely important. So we are experimenting with a hybrid system. And we are just on the journey for doing fine tuning. One of my teammates has putting a service for fine tuning as a service in which we are taking embedding models, adding domain specificity, and making it happen so that all the different teams can use that and create their own fine-tuned version of the retrieval of the embedding model. So we are in the process of adopting that. So it's a bit too early to see some of the results coming in, but we are hopeful and optimistic that it'll work for our specific domain.
Can I just jump in real quick? So my team has also done some retrieval. In fact, if you go to the MTab leaderboard, one of the best models that is under 500 million and high quality for information retrieval is Arctic Embed.
Yeah.
And so my team sort of fine-tuned our own retrieval model. We created Arctic 2. Yeah. We recently are going to release also Arctic 3, which is an instruction following retrieval model. If you're looking to fine-tune, you should talk. But sorry, I'm not going to push that any further. But I think it's just the scale really matters. The quality really matters. There is some art and science to this, and in hard negative mining and things like that. And I think it really helps even if you take a small amount of domain specific data and get the retrieval fine tuning right, it can actually really help. And so yeah, I mean, but just a plug for the two papers that my team published, which are all about how can you fine tune your own retrieval model or embedding model.
I would just like to add two more points. Thankfully, the embedding models are designed to run on CPUs. Okay, so it is a disservice for us because the expectation is when people think about fine tuning, the naive approach that they think is we are talking about fine tuning large language models, which is very expensive. Okay, but here in the RAG use case, we're really talking about fine tuning the embedding models, which is a completely different beast. Okay, and that should not be compared with the G part of the LLMs. So it is, in my opinion, a disservice if we do not fine tune the embedding models because the payoffs is huge in terms of precision recall. And it is cheap enough to run on regular CPUs. You do not need GPUs unless you're doing mass scale, different very outer use cases. So to me, that's one. A second point I like to add is about the dimensionality of the embedding models. A lot of times this is tends to get ignored, and it often follows a bell curve. So a larger number doesn't necessarily need to be a better one, because it does tend to burn, CPU resources, disk space, and everything else associated with it. So, it's a very naive approach in terms, sometimes the team members just put in a default number without understanding the implications of that. And they are sometimes unable to choose whether it's 100, 500, 1,000, or maybe they go extreme, in which if the embedding model is supporting a 4K, they go all out 4K.
By the way, one trick we do here is what is called Matryoshka representation learning.
Yes.
And so we have this thing where our models have 768 dimensions, but you can also use them at 128, 256,
Very well.
512. So that seems to work pretty well. Yeah.
That's a very great strategy. I'm sure, hopefully Asif will also cover the advantages of that as well.
Asif, so taking this to you, just take us into embeddings and all. And I think dimensionality, like Dhananjay mentioned, if there is some more insight into the choice for dimensionality of the model.
Yeah, sure. See, so first, let me close the topic of why do you fine tune? If you think again about that globe, you don't want your particular domain's data to just occupy one little region of the globe. You want it to optimally use that. More mathematically, you say you want to solve the problem of anisotropic distributions. But intuitively, just think that you don't want all your data to just go sit in Australia. Then comes the question of dimensionality. It's actually quite simple. So I'll give you an example. Suppose you had only 2 axes. Now you have cows, ducks, and horses. You say, well, that's very easy. Along one axis is size, another is the weight, and I can put cows, ducks, and horses. And the meaning of the 3 are captured by these 2 dimensions. But then suppose you bring in an attribute, rideability. You can ride a horse, but not a duck or a cow, right? So, well, now you need another axis. Now you bring in a sofa. Well, you don't want to call the sofa and the cow, even though they have the same size and weight, as the same thing. So now you bring another axis. So you soon realize that the more dimensions you add, the more semantic expressivity you gain. So more dimensions are good. But then dimensions come with a problem. I often say that Harry Potter stories had their curses. Then we people in AI, we have our own lovely curse. It's called the curse of dimensionality. Right? What it basically means is that in high dimensions, everything runs away from everything else. In Bay Area, if you want to talk to your neighbor, you get your hand out of the window and knock on your neighbor's window, and the 2 of you are talking. Right? In Wyoming, if you want to talk to your neighbor, you get into your pickup truck and drive for an hour. Right? So the concept of neighborhood changes in Wyoming compared to Bay Area. In high dimensions are like Wyoming. Everything is far away. So that leads to a whole variety of problems. It's just too much space there, right? Now, in between, somewhere is a Goldilocks regions. It turns out high dimensions actually comes with a blessing that's probably not as well understood. It is called the concentration of measures. It's a very peculiar phenomenon. It's a bit hard to grasp because in 2 dimensions and 3 dimensions, you don't see it. What happens is if you just take random vectors in 1,000 dimensions, do this experiment, generate 1,000,000 random vectors. Take one vector and see what is the angle it makes with all the other vectors. You will notice that every other vector that you generated is trying to avoid it. They are all at 90 degrees to it, more or less. So if you think of this point as sitting on the North Pole, they have all run away to the equatorial plane and staying away from it. So what it means is that a vector and something else that's random to it will be far off. But the counterpoint to that is something that is semantically relevant, because this vector represents a thought. If another thought is genuinely semantically relevant to it, which is what you need in search, it will actually be in a very sharp conical cone around it. That's called the spherical cap. And that actually is the real reason semantic search works. So sufficiently high dimension, not million dimension. You notice the dimensionality ranges typically between 100 to 4,000. 8,000 is pushing it. This is your Goldilocks region. This is the region of optimality in which you choose. But even within this region, if you stay low, you lose, like you do have it's not high enough dimension. Random documents have a chance of showing up in your search results. But low dimensional vectors are easy to store, fast to compute with, very fast retrieval. And so there is a concept of Matryoshka embedding. What it does is it says, let there be a ranking of relevance. Most important dimensions, like when it comes to cows versus ducks, surely weight and size are important. Make them the early dimensions and the other ones the later dimensions. And then what you do is store two embeddings, just a chopped down 100 dimension embedding or 50 dimension embedding or whatever, and then the full vector embedding in all its glory of 4,000. What you can do is, and this is where the hybrid search and all of these things come in, re-ranking comes in, you do a very fast focus on recall. Get every document that seems relevant. It's like a child scooping a lot of sand on the beach. It may have some seashells. Then recall is improved. In the next stage, send it to the re-ranker. Let that one work mostly on precision, shifting through the sand and just keeping the seashells that you really want to do. So there are a lot of these techniques. Also, never underestimate the fact of keyword search. Quite often users use very simple words and they have many meanings. If I use the word bank, semantically, it could mean any one of the things. Financial bank, right? A river bank, your friend banking on you to get the pizza, right? An aeroplane banking, the road banking when it curves, and so many things. So semantic search wouldn't actually do so well. A keyword search, it turns out that in such situations tends to do slightly better. It has a more statistical awareness of, in this particular domain, which tends to be more often used. For example, if you're dealing with financial documents, it'll pick it up more. So you always use keyword search, semantic search, hybridize the two, and you use multiple things, low dimensional queries, fast retrievals, feed it into the re-ranker. So that's the sort of the mechanics of the nuances that makes retrieval systems work. But there are two other things that I would like to talk about. One of them is query transformation. The weakest link in a RAG system is actually the user. We write things with typos. We ask questions that are ill-formed. So you notice that ChatGPT, Gemini, Perplexity, they do an amazing job in still figuring out what you mean. That's the query transformation layer. You need to canonize the query so that search results are better. You need to also determine, is it too trivial a query? Just forget the retrieval system entirely, send it to RAG. So your system is about finance, or let's say security. And somebody asks that, oh, why are roses red? Do you really need to dip into your vast enterprise knowledge base? No, you send it straight to the LLM. The counterpoint to that is, if you have a multi-hop query, suppose the query is, where did the author of, let's say, Mill on the Floss, a book, Mill on the Floss, spend her early childhood and how did it impact her outlook? There is no way you can answer this question with a single straightforward search. It is a multi-hop search. So all of these things, you need a query transformer and an agentic system that immediately understands what's happening. It should know whether it's a point query that can be answered with chunks, or is it an abstractive query that should be best answered through a sidecar of graph RAG and so forth. So anyway, retrieval, to the point that all the gentlemen here are making, is far, far more important than it is often given credence for. And so people have a perspective that it's all about the LLMs. No, it's a lot to do with the retrieval system. You get this right, you're well on your way to creating good RAG systems.
Thank you, Asif. And we're going to now have our last question for the panel before we open it up for questions for the audience. I guess just tying it up all together for the audience, if all of us, you all could tell us what the non-negotiable components for RAG would be, and also some insight on what are you all expecting and changes in 2026. How are you all expecting your RAG systems to change in 2026? So Djay, can I start with you on this one?
Sure. Some of the non-negotiables. I think first and foremost, I'll start with guardrails, making sure that we do input and output scrubbing. I think Asif mentioned about query rewriting. That's one of the ways how we can, first and foremost transform the query itself, but we put in the guardrails. Some example is, if I want to ask, let's say I'm a fintech organization in an enterprise, if that's the implementation, and I ask a question, who's the president of United States? it's not really, a helpful question, a domain-specific question for the system that I've designed to implement. So, maybe that is something that should be discarded. So putting in the guardrails so that you're not flooding the system by either non-domain specific queries or nonsensical queries. And the guardrails can be things like gibberish detection and so on, so that you're not overwhelming the system. As Asif mentioned, user is the weakest link in the chain. You cannot control your input to the system. So making sure that your query input response processing is also scrubbed and filtered properly. And the output response is also scrubbed accordingly, in which you have put in your output is scrubbed for authorization, security, constructs, and so on and so forth. So for me, that is fundamentally, guardrails is one of the most critical aspects of making sure that apart from the stuff that we've spoken about today, to me, it's a non-negotiable. And where do you see it evolve? I think in 2026, the way how industry is changing on a weekly and monthly basis, I will not stick my neck out to make any predictions.
Too long to tell with tech.
Yeah.
Rajesh, the same question for you.
Yeah, again, similar response. I think working for a security company, I feel there are two very important aspects. Guardrail is definitely important. We deal with solutions every day, now and then, like working with security team. Lot of data has PII, right? And if that PII data is going outside, like if you are processing via OpenAI or Claude, whatever it is, you don't know what they do with your data, right? So guardrail is very important, redacting PII data, making sure the prompts cannot be injected like a lot of hackers trying to do, injecting your prompt and doing harmful stuff, right? Those things are really important. And next best important for me is like role-based security, which is critical whether you're querying relational data, where security becomes very important. You cannot get additional information that a person is entitled. You need to get that information. And with structured, that becomes very difficult, but again, very important.
Rajhans, could you tell us the non-negotiables, and are there certain specific goals that you all are trying to achieve in 2026 with your RAG system?
That's a bigger question. But I think for the non-negotiables, I agree. I think security and RBAC and all of these considerations are significantly important. They'll continue to stay important, right? Of course, we can make it interesting, right? We're like, things are changing. What is your prediction about 2030 that you think you are gonna willing to stick your neck out for, right? And I think you would probably stick your neck out for like security is important. You probably stick your neck out for prompt injection attacks are going to be a problem. I don't see us solving them really well. So it's going to be a continuous battle, right? I'd probably stick my neck out for, I don't know about the architecture of the RAG system, but the retrieval as a tool will stay important. I don't see that getting solved really well. In terms of other things, I think just getting the data ingestion and all of those things right still remain messy. Still will be one of those things. If you were to solve, we'll spend a lot of time. It might become easier. It might become easier to configure all of these things with the rise of coding agents, right? But so you might not spend like 6 years doing this. You might be able to do this in 6 months, but it still is going to be sort of an important component of the things that you want to solve. Other non-negotiables, actually, honestly, not that much. Like, as in, I'm not gonna like say, oh, this is the architecture that I think is going to survive. Probably not. So RAG itself, some people say RAG is dead. I don't think RAG is dead per se, but just RAG has evolved, and retrieval as a tool will stay. But the architecture that served us from 2020 to 2024, that perhaps might be dead, which is these one-time retrieval and generative architectures. It doesn't handle multi-hop, doesn't handle various different things. But other than that, yeah, nothing else comes to mind, to be honest. Yeah.
I would like to add, I hope to see evals become a non-negotiable this year, because I think the end-to-end working of a system architecture that's heavily dependent on the evals being done right. And these are the ones, as Asif mentioned, should be done by non-engineers to truly put the meat in the matter, and done ideally by subject matter experts or product managers who are close to the system and who can act as the voice of reason, the champions of the system, and put in the the evals in place so we can measure the accuracy and make sure the system is working as expected. I think this is currently underserved in the industry because we're still in that kind of pilotish mode. But as we go towards outcomes, which is driven by a very scientific evaluation-based process, I really hope that this becomes a mainstream this year. I put in things like AI observability and put it in the right system so that we are capturing all the user inputs, responses as the user is using the system, and constantly measuring the accuracy and making sure we can converge to the target state.
Thank you, Djay. Asif, just coming to you finally, just, the non-negotiables that you can think of just to ensure or at least attempt to make our RAG systems good
Yeah.
with whatever
Actually,
good is.
Yeah, most things you mentioned, evals, guardrails, security. Evals in particular, if you can't measure, you can't improve it. It's a truism, right? Going back to Lord Kelvin of thermodynamics. And in fact, it is not even science, right? The, uh, the other two non-negotiables that I would like to add is, one is a refusal to answer. See, if you get a question that is about religion, politics, or has hate speech, trust me, there are no correct answers, right? You need to trap it and remove it as part of guardrails, and you must have that. The other thing is what in quotes we say, tell the truth, the whole truth, and nothing but the truth, right? So does your system at the end of it come up with partial facts, or does it tell the whole truth is important? Does it even tell the truth, or is it hallucinating? A good RAG system should say that based on the facts, these things we know, but there may be other aspects. It should be able to see. This is called well, they're more formal terms, epistemic uncertainty and so forth. It knows how uncertain it is about the answer and then decides whether to do exploratory search or not. You should have that. And above all things, a good RAG system, in my opinion, non-negotiably should be able to say, I don't have enough information to answer your question. Right? That to me is non-negotiable.
I'll just add something more with that clicked based on your answer and response. I think a good RAG system should also show its transparent reasoning process as well. Giving references, giving factoids, giving articles. Like when you go to Perplexity, it tells you the relevant links where it can back up the data, the citations. Yes. So I think that is extremely important, for a good RAG system to do. And going back as we going more towards enterprisey data that Rajhans is trying to solve, about aspects like text to SQL. That's hard, especially when LLMs are non-deterministic, right? Unless you've created a rules-based system, which I don't think we are. Okay. So in that case, how did we infer that this translation of a required text to its corresponding SQL is actually factually accurate and the reasoning behind it? Otherwise, it will quickly lose confidence about when a data set is retrieved and created, what was the reasoning behind the intent to its a relational transformation and fetching the right results. Unless that is shown to the end user, something very similar to what citations have done for Perplexity, it will fast lose value in the enterprise. Rajhans, any comments?
I mean, I think it depends on the user, I suppose. I mean, if I'm showing this to the business user, they anyway don't know how to interpret the SQL. So if you're building a BI tool and I just show the results, I can show the SQL, maybe they'll understand. I mean, we kind of gone back and forth on this, and we realized, at least as far as text to SQL is concerned, there is one product for analysts and there's another product for business users. But I generally agree that showing reasoning kind of helps build confidence. And there are, of course, other ways of doing this. You can show thinking tokens and all of that stuff that can actually show how you're thinking about in this process, and that actually helps build confidence. But we're still figuring it out. So I don't know. Maybe something new will happen.
Thank you so much. And I think now we will open it up for the audience for any questions. So does anyone have any questions that they want to ask the panel?
Early on in data wrangling, you mentioned the issue of keeping things up to date. People have all kinds of mixed expectations about whether they can get the data that's been freshly updated, especially in breaking news or so on. So there's an issue both of caching and of keeping your retrieval systems up to date. What have you found as practical tips for dealing with what user expectations are for keeping the access controls up to date? Because a document that was public or is now restricted to a certain work group, how do you make sure it's in there? And of course, also the worst cases in fine tuning and so on, which is tracking, did that taint further learnings? That there's now people downstream that have learned from that data that's no longer available. So invalidating documents or updating freshness or adding is one thing, but how do you also handle that, or what have you seen as patterns for dealing with changes to access control?
I'll give you my experience how we are using it. So as we integrate with multiple systems, like we have created our own connectors for Confluence, connector for Google Drive, Jira, and so on, we highly rely on last modification date, whether it's timestamp of the file when it was updated or a record that was updated. So that's a triggering point to take that information and do a complete reevaluation, right? Look at the security. Does this security change, right? Did the file change? So we take that information and do the reprocessing. If the permission has changed, we'll have to update the metadata. The only challenging aspect we had with deletions, again, we had to maintain that event queue, like if someone is deleting, push it then to queue. So we take that information and delete it. Because if you're not doing that right, you're really asking for trouble.
I mean, it's a practical matter. What are indirections? Like this document is available to anyone on this mailing list, and the membership of the mailing list changes. This is where like Glean and other things have run into interesting precedents. But I was curious what the state of the art is.
Right. Yeah. It's a tough problem, but I think a lot of time gets spent over there.
You can also do request time checks. So like request time, you can do at that time, you can just check with the system that has access. It might add some latency, but might actually work. But in terms of indexing, I think it's kind of hard to give guarantees, I suppose. You can always say we have 30-minute freshness or 1-day freshness, depending on the system. I think you can do like 24-hour freshness. Many of them have sort of different limitations.
And you'll have to build a strategy around it. Like you might want to do incremental updates on a daily basis and might want to do full refresh every weekend, right? So again, you have to come up with different strategy depending the importance of data to be available. So it all depends on that.
Yeah. So I'll give you a solution, which is not a perfect one. It's a very complicated problem. But let's say its virtue is its simplicity. What you do is when you index things, let's say in a vector database, you attach metadata to it. So you attach what roles can see this data. Then when in the retrieval part, have a filter. Whatever the top tier results come, prune it based on this user's access control, role-based access control. And so what goes to the LLM is that which remains. And the LLM must craft its answer grounded on only those results. That sort of works, but it's simplistic and it's certainly not comprehensive.
If only they weren't Turing complete.
And again, getting role-based information from each system, that's itself is a challenge. Like getting role attributes from Confluence is different than Google Drive, than Salesforce, which is like really complicated role mechanism. So you can get the complexity it gets to.
Anyway, thank you all. The important part is that it's not currently a barrier to commercial deployment.
Yeah, to me, this is a classic enterprise integration challenge. There's no one size fits all. I mean, this is going to remain an open challenge. I do not foresee that there will be one product will solve all of these problems of versioning, index updates, security, etc. This will remain I think a company specific challenge because of the disparity in different systems.
But these Salesforce are counting on doing federated searches, right? So that's the other solution.
There's a lot of large players counting on them being the only endpoint. Like,
Do we have any other questions that you all want to ask the panelists before we open? Okay, we do have a couple of questions. This side. Wait, they're just. Oh.
So as you said that the embeddings are domain specific, but what if the same data set is meant to give insights for different domains? So do you expect the same data to be re-embedded for every domain differently?
Yeah, it's always good to create multiple embeddings. See, what happens in real complex retrieval systems is you have a fan out and fan in system. Like, for example, one simple architecture is you have a classifier that detects which of the topics or subjects it is pertaining to, because you maintain different vector indices for each of them. So they all emit their top tier results, and then they all go into the re-ranker, right? And because then you have the luxury of having really fine-tuned embedders for these specific things.
At the time of inference or at the time of query, the input embedding should match, and then the
That is right.
okay.
See, query comes as user text, right? And then that's where the routing part comes in.
How big is your data? I guess it also depends on that.
Yeah.
If it's big and you don't want to pay the cost, then I think it's a different thing. But
I was about to cut to that next.
So it depends on how many classifications. I mean, this can be a very lightweight, extremely fast operation. The moment the query comes in, gets classified, then choose the right embedding model, which is domain specific, and then process.
You talked about the freshness of the data and daily, hourly, and RAG systems, especially in the usually you're looking at that type of latency. I was wondering, in experience that you have in building security systems, financial services, there are use cases that those latencies are not acceptable. You're looking for sub-second latencies. How do you kind of like bring that type of data or context to bigger applications that you're building?
So in RAG pipeline, sub-second latency, not possible right now. So yeah.
Beyond that, if you build that use case.
So again, like depending on the nature of documents, how important it is, yeah, you can run that pipeline multiple times. But again, there'll still be some threshold, 1 hour or whatever it is. And that's the expectation we set upfront when we are building application for a particular user for a particular domain.
I'll take a stab at it. So it all depends. Look, I'm sure you know the exponential curve, right? For example, for any metric, say uptime. With the moment you go from 3 nines to 4 nines to 5 nines and add every 1 9 associated, the cost is exponential. Okay, same thing happens with latency. The moment you want to reduce the latency down to every 1 order of magnitude, the cost also increases dramatically as well. So I think a similar law applies over here as well. So if you're looking for more of a real-time semantic search system, which is near real time. Okay, near real time to me is like order of a magnitude of few seconds. Okay, to me, it really depends on how big and fat you want to create your ingestion pipeline. Okay, if you can throw GPUs at it, and get the document ingested really fast, really quick to your vector store, okay, that is where the biggest cost is. Okay, so that your retrieval can be done. Okay, so if your document is changing, let's say every half a minute, every 30 seconds, and you can do ingestion of that document in less than, let's say, 2 seconds, maybe it is ready for retrieval in less than 5 seconds. So it all depends on how do you define the problem space, how much, what resources you can throw at it, and it's a scaling law.
Yeah, I'd like to add one thing. See, when we talk of latency, then there are two aspects: how much compute you're optimally willing to give to it, and also what is the quality of answer that you want. And so each of these is a desirable. We would want the best possible, most thoughtful BI dashboard to pop up in response to our query, but we want it to happen in the blink of an eye. And of course, the compute cost should be close to zero. So all three desirables being there, you think of it in terms of a Pareto frontier, in which like you try to optimize on one and you pay cost on the other. And you have to pick a point on the Pareto frontier and that you're comfortable with.
Yes, you have already solved it, so no.
No, I think I asked the question the wrong way, maybe, because as you mentioned beyond RAG. So RAG, as you said, for documents, it's the right way, but you may have different dimensions for doing your inference and answering the questions or an agent taking an action. So in those cases, RAG is one dimension, right? And there may be other data or other contexts that would be supplied to the inference.
That's correct. RAG is a foundation like knowledge used by, okay, like if you're building a multi-agent system, you use RAG as a input where you get information, and then you look at other sources also what you want to do, right? So it's all applicable here.
Do we have any more questions?
Yeah, I had a question. So this is more so regarding more sensitive data that you guys be working with certain organizations. So with all the efforts that's taken to scrub the data of personal information, considering RAG as a whole, have you guys experienced the hallucination part still affecting the masked out areas within the generated text? And if so, what sort of post-processing strategies have you used or experienced which has really done wonders to still provide a much cleaner output to the user?
I can take a cut on it. So one thing we didn't talk about in this thing is like system instructions on how you build your system instructions to answer your question. So the way we have done is put a lot of emphasis on system instructions, and when you're getting the data and how you're portraying the output, hallucination is minimized, right? Because you want to prompt the LLM to stay within the context that is being provided and not go beyond that. I know we were talking about like answers coming as I do not know. This has become a big shout out from our business users. When they get I don't know, they feel the system is not working. But they don't understand, okay, you're asking a wrong question and this doesn't have that information. That's why it's not coming. So I would rather apply strict rules from instructions perspective rather than keeping it open and give more information.
And I'm assuming these instructions are industry specific because, for example, the law industry may have some highly sensitive data that you do not want to get, you don't want shared with anyone else. So I'm assuming that would come from industry.
If you're talking about sensitive data, I would apply guardrail on the front, right? So again, you can control for specific users, don't redact any PII data or redact any of the information. So you need to start applying that because RAG cannot do that by itself, right? So you have to apply guardrails on that. And there are a lot of solutions available today in the market for guardrails. And again, guardrails can be applied both ways. Before sending into the LLM and post LLM also, you can apply guardrails. So you need to do both ways.
And apart from the guardrails, you can also make it an agentic RAG system in which there's also an agent sitting in with some domain specificity, and you can instruct it to, apply some filtering of the responses as well.
Hi, I have a question in regard to how you see the role of startups in this ecosystem. So we see a lot, I'm an investor and I see a lot of startups that claim to do certain things to do with RAG, whether it be with the data preparation, whether it be with working with specific verticals. But I find that it's very difficult for them to scale and deal with the compute that the big players are able to do. So from a general themes perspective, where do you kind of see areas that you might not have the time to work on that you think startups could fill that gap? Whether it be as a founder or an investor?
I'll take that question. Actually, we give workshops on RAG, and we have had the pleasure to say that in the last 2-3 years, 17 startups successful have come from those. So I'll give you a characteristic. Don't try to build horizontal platforms. There, the perplexities, the clouds, the Snowflake, etc., they'll do a better job. It takes vast technical depth to build those. Unless you have core IP or breakthrough, that's not very business savvy to go there. But I'll give you examples of startups that are no-brainer. Some of them may be fun and some are of business value. In South India, there's a cultural tradition. It is called, in Tamil Nadu, it's called the Tirukkurals. It's a vast amount of literature. And no matter what problem you're having in life, it has something to say. Think of it as a cultural built-in psychotherapy, right? Or a support system. One of the students, what he did is he took a lot of such traditional literature and encoded that into a RAG system. It's actually very popular. Now the government of that state is taking an interest in it. Another, which is in a previous batch people were doing, was we looked at the skin. See, what happens is that in remote frontier places, medical access is limited. So you have a skin condition. The range is it could just be a scratch or allergy, or it could be a melanoma. Just show it. It could be a snake bite, right? Or snake bites are a special class that they're dealing with. You can just show it to an optical system, and without playing doctor, it can do primary care. You know, the people who are primary care in the frontier regions, they're not playing doctor, but they're at least giving you basic guidance, building a system that is getting some traction. Another person did this. What he did is, so many of you own homes, and when you own homes, God forbid if you build anything too close to the fence or plant a tree or something like that. There are regulations. Each city has zoning laws and so forth. And they are often very different and nuanced by cities. So this team took all the zoning laws, and they realized that the documents are terrible. One of the things they did is they took the documents and they rewrote it and used AI to rewrite it and make it more explanatory and build a RAG system on that. Actually, they're already getting interest from people to take it forward. So what's the common denominator to all of that? Start with the real world problem and solve it. Don't think technology first. Think real world problem that needs solving. And if you think of it as verticals, you know, there are a million verticals you can think of, a million problems that you can do. And guess how many of you have ever thought of solving any one of these problems? No, you have no competition. You have the luxury of time. It doesn't take too much resource to build a startup, and you can go on with it.
I'll also take an attempt. I've also been a couple of startups in the Bay Area, so I can share. It all depends on the ambition. Let me start with that first. Okay. Is it like your boutique startup that's, maybe good for you personally? It's like maybe you're thinking, hey, maybe this is, big enough for me that I can sustain myself. Maybe like 5 mil ARR or something like that in that space. That's a very personal startup, right? Or do you want to have larger ambitions, okay, in which you want to maybe enter a one specific vertical area, maybe healthcare, define, be focused, okay? Or do you want to become much bigger and larger, expand the scope? Maybe you want to become another unicorn, okay? That size of a startup. And the problem set is large enough. But most of these folks who became big were also startups at one time. So look at the history of some of the recent successes of last year, 2025. Take Cursor as an example. I mean, when they started, they didn't create an LLM. I mean, they forked VS Code as an IDE, and they put in their magic sauce to make it very highly fine-tuned for the developer experience, which resonated very well in the market. Okay, so that's a big success story. Perplexity started off as a very simplistic grassroots effort of putting a really nice RAG system on top of LLMs, etc. So if you look at both these two success stories of Perplexity as well as Cursor, they didn't radically create the foundational technology, okay, but they built the value add on top of it to solve that specific area, which is having enough buyers or users, which makes it extremely valuable. Okay, so startups is all about value creation, resonating with the end users and making their mark so that it gets wide adoption. So it really depends on your scale of the ambition, and if you can find that niche vertical where you can make a mark and add that value.
Just to maybe add something, maybe building on a little bit on Asif, but maybe taking a slightly contrarian point of view there, right? I think there is at least if you're focusing on what you call largish things where you want to create a lot of value and then capture a lot of that value, right? There is a little bit of a threat, which is whatever you do gets co-opted by Anthropic and OpenAI, right? Now, if you have a snake bite, detection as a startup, I can also take my photo and upload it on ChatGPT, right? And that might actually work pretty well. But that all being said, it's possible that if you if you are serving a niche community, then that actually is fine, right? But then, of course, your TAM gets limited accordingly, right? So there is a little bit of like, right now we are at this weird point where we are like, whatever you do you think ChatGPT and Anthropic and Anthropic's co-work thing came out yesterday, right? It sort of wiped out a bunch of startups effectively, right? What is that space? And I think there is maybe, I don't have a great answer to this. If I did, I might be doing something at some point. But anyway, but I think there is something to what Asif mentioned, which is if you take a vertical and you think that vertical is underserved in some sort of a technical way, not just in a sort of a different way. So to give you an example, if for example there is a bunch of zoning laws from different cities, right? And then zoning laws are of course part of the LLM training data, but it's 10,000 documents out of billions and trillions of whatever documents, right? So the LLMs, while they can use RAG and something to look up these zoning laws, they might not have very good recall of it, right? So if you really want to create a high quality zoning law based system, you've created a good system where you've ingested all the zoning laws, put them in a retrievable form, and so on and so forth. Now your quality is going to be significantly better than likely whatever ChatGPT and Anthropic will come up with, because either they will do RAG and retrieve some terrible document, or they will have memorized the document but will be one of the various documents, so they don't really remember it very well, right? So there might be some sort of technical advantage in a particular vertical. Similarly in medical, something else, like maybe wherever there is the data source is proprietary or things like that, and then you can ingest that and do something better with it. And then of course there are other arguments which are independent of LLMs, which is you come up with some use case, you have a particular insight into some sort of a vertical, you are a lawyer and you know how something about law works, and you're a doctor, you know something about how the back office in a hospital works, and so on and so forth. Those arguments still apply, but maybe there's some nuances that have changed in the LLM land these days. And it's kind of hard to capture those nuances, but I think it really varies it's on a case by case basis.
Thank you.
Hello. Thank you to Silicon Valley AI Hub for convening the distinguished panel tonight. I was very pleased to hear that the litmus test of a good system is that it says, I don't know, because my small research system does do that. So I'm really pleased to hear that. The way that we handle that is in my small research in a university environment focused on research material, PDFs with tables. And the way that we handled that is that we don't say, we, the machine, don't know. We focus on their query. We say, your query does not contain elements that we are familiar with, or something like that. It puts it on the user, and it's a different psychology, right? Anyway, I have to admit, I'm a little unsatisfied with the talk tonight, because it seems that the input data, the raw materials of the input are insufficiently distinguished in your conversation, because very formal research papers in science is a very different thing than ad hoc conversation. Everybody knows that, but you can't give one answer without distinguishing which you're talking about. So we could do better in the conversations, I think. And then similarly, the answers that you provide also have a range, because we have a system that is working now that is a chat system. So people have a chat interface on Matrix, by the way. And the chat system, people who are in a chatty kind of point of view often expect a chatty sort of response. And that is very different than a fully specified and detailed with references response. And there's an implication to the UI also. How is this presented to the user? It's software design, right? Anyway, I just want to say thank you for the conversation. Many, many elements in it. And there's a lot more we could do better with this conversation, I think.
I certainly would agree. Partly we have a limited time, but I'd like to talk about the point that we don't know. It goes to the epistemic uncertainty. If the LLM is still unsure, there are reasons for it. And of course, good response system should not only give where it got the answer from, the search results, the highlights of those, but also should give follow-up questions. And that's a great place to say, well, I couldn't find that, but is it what you were looking for? Or could you, these are the elaborations that you could give. The other point is definitely true. Research papers, everything better be grounded. And quite often the references are longer than the paper itself, right? But that's not the nature of normal conversation. So the texture differs, and domain specificity or use case specificity does matter a lot. Right? Excellent points. Thank you.
So could you talk about a little bit on the infrastructure side, how you deployed, because all large enterprises here, whether it's on cloud or on-prem kind of?
Yeah, for, again, being a security company, most of our solutions are deployed on AWS, but private cloud, because we don't want to send any data outside our domain. Even like if you look into LLM models, we use OpenAI, which is on Azure. We don't use OpenAI's OpenAI, right? So everything is within the boundary, stays within the boundary, any solution that we talk about. At the same time, from infrastructure perspective, you have to think about the right infrastructure for your vector store, right infrastructure for other solutions that we have. Then you need to have a great ML ops system also. You need to have great observability platform. So a lot of different things comes into play. One thing, yes, we have struggled in some of the cases, like where you want to deploy a solution and that solution is unfortunately not available in private cloud. If we go with that solution, a lot of discussions happen within our security team and the vendor team. So it's like, and again, we'll go with like dedicated instances, right? So, and that's again, it will depend on company to company. Some companies just want to go everything SaaS model and they're okay with that. We are not.
Gee, if only there was a data cloud that had really good role-based access control and offered out-of-the-box hybrid search, and you could call your LLM without the data ever leaving your security perimeter.
Had really big buildings.
And have big buildings, right? So big building show it's a solid company.
We use a mix of everything, depending on the use case. So we do on-prem where it makes sense. We also have our own GPU clusters, etc. And we also use cloud providers. So it's a mix.
That's all for questions. I would just like to thank. Okay.
For systems operating between, for your on-prem and on-cloud communication, especially agentic systems, how do you ensure security? Like you need to verify, like if one agent is communicating with another.
Are you referring
shared-
to agents which are custom developed for a particular company talking to another agent across the system, like agent to agent communication across boundaries and processes, or what exactly? Define the problem a bit better, because there are many different permutation combinations.
Yes. So there is always a security vulnerability if you are moving from on-prem to on-cloud. We can, for simplicity, consider your own company use case, where it's your own.
So are all the moving parts, all the different agents part of the same company?
Yes.
Okay. Do they have the right network boundaries, like VPC peering and all that set up across networks?
Yes. Let's consider all that is there. So
If
do you?
all that is in place,
Yes.
okay, then it really, security is completely into your own hands.
Mm-hmm.
So it really depends on what security do you mean. Security is such a big, wide umbrella. I think we can do a bit better with more problem definition.
Got it. No, I was just curious whether in case of Gen AI or like, these kind of applications, are you using additional measures than what we have traditionally used with other applications when we have been communicating? So are there any special guardrails that you have? Because
you're not relying on an external system to handle.
Certainly.
There could also be some frameworks you might be using from AWS. Like, for example, it has an agentic framework you might be using that gives you good, they have come with a mature capabilities around caching, right? But now when you're using those capabilities, get into, more advanced systems, because for enterprise, you need to, have a lot of metadata, to answer faster with low latency, especially in cybersecurity space.
Sure.
The systems keep getting complex and complex. So
certainly.
And you need to have guardrails in place, security, context shared properly. So if anybody of you would like to, share.
Certainly. Yeah. So in short, I think there are security it's a layered approach, right? We're talking about aspects like, are we talking about network level security, transport layer security, security
Service
at rest?
level, like
For example, when we have data, is it data security in motion, or is it data security at rest? Or is it application level security? Is it security related to authorization, who can see and cannot see? So it's a very big, broad definition of
what
security.
I was referring to was agentic communication, which is in motion. So
Okay.
like sharing the auth context, maybe,
Certainly. Yeah. So maybe I'll pass it over to,
like
I may not be the
traditionally-
best person qualified to talk
Yeah.
about this.
Yeah,
I'll take,
traditionally
If any
we've used
takers
like service
from
to
the
service.
panel? Okay, let Asif.
Yeah, if I may take a stab at that. See, and I'll just make first a broad statement. See, the arc of technology always is something very exciting comes up, then it is found useful, and then everybody worries about security, right? You see that arc happening. RAG, it's indubitably proved its value. And so we are now trying to shoehorn security on it. Since you spoke of agentic, if you look at the MCP standard, Model Context Anthropic, they have given it now to the Linux Foundation and all of that. One of the key features, in fact, the defining features that they introduced in the last few months was exactly around these enterprise and security related aspects. The Google agent-to-agent communication protocol also is now taking the security aspects. So I would say it's following the normal arc in which first you get the technology right, and then you begin to worry that, okay, we need to make it enterprise. Is it work in progress? Very much so. Is it something you can fully trust? I don't know. I don't think so. It's still very much a work in progress.
So I would just like to add one thing. It gets more complicated when it goes to like MCP outside of your organization, right? And so I've been into some forums that were like private VC events where there were like startups discussing ideas. I'm also a partner in one of the funds, and I've been an architect in security companies before. So one of the things that I have, heard as one of the trends is concept of zero trust applying on MCP. So I was very curious when I asked this question. I was hoping to hear from you if you have some thoughts around this.
No, absolutely. And we are actually doing a lot of things around this area, right? First of all, we are implementing a framework within our organization where you can deploy external MCPs, but we are creating a proxy virtual server in-house, so everything gets passed from there. Now, the advantage that we get with this proxy is like you can start integrating with your own tools and everything like guardrails. We have our own product called as AI Guard. We can ingest that. And we can ingest within like observability, so everything is happening. The other thought process is like agents, right? Where it is autonomous and all those things. The approach we are taking is converting that agent to MCP tool and make that authenticated. And we have made all these handshake between Okta OAuth versus MCP OAuth, because eventually MCPs are applications that are protected by Okta. So we are making that handshake, and everything goes through this proxy services. So everything is secure, and you capture each and every log that is happening.
And MCP supports
these
OAuth 2.0.
now. Are these available for companies to use? And
yeah, so there's a open source product. Look at it's called as Context Forge. It's created by IBM, and they recently went with 1.0 release. We have taken that source code and did heavy customization, which gives you MCP proxy. It also gives you Google's agent-to-agent protocol, which converts into MCP and all those things. And it does support OAuth authentication and integrating with your SSO.
Thank you so much.
There's a bunch of security startups that are also started looking into it. a mutual friend of ours is doing a startup
Yeah,
as
I
well
know,
in this
I know.
space. So there's a bunch of people who are actually all looking into MCP security and providing more, basically to your point, agent auditing and audit trails, etc., for all of these services.
Yeah, I can just add some more flavor. So now I get more specific context about it. Let me try to answer that. Okay. So in context of MCPs, as you know, MCP became a huge standard very quickly, and then we bolted on more standards to it, starting with OAuth 2.0, and then we added 2.1, and so on and so forth. Right. So it is maturing as we go, and there are two flavors of MCPs, as we know: local MCPs and remote MCPs. Okay, and they both, deal with a very different set of problems. Remote MCPs are hosted as a service versus local MCPs, right? Which you can control, and you are more in control of its deployment as well. So, within our org, we have created our own version of MCP Hub, or call it MCP Registry, which acts as the entry point where we publish our own MCPs. That makes sure that we can avoid supply chain attacks, which is one of the most common things, okay, in which we create our own MCPs, we publish to our own registry, and we consume it internally. So everything is end-to-end covered, so that we don't rely on third-party NPMs. Hey, blindly go to NPM registry and download any random MCP, right? So we definitely avoid that by having our own supply chain very, very clear. Okay. As Rajhans mentioned, one of our other friends, he's also doing his own startup, doing an MCP registry, which has got pretty good traction in a lot of different companies, large enterprise companies, and he's doing an advanced version of it, which has many different facilities with a security first architecture. He's ex Okta, so ex Google, so he knows his stuff, and hopefully he gets a big success.
In your case, do you do the token exchange and all of that is implemented there? Like in your MCP registry and all of the SSO?
Yeah, so we do, but it's an internal mechanism.
So you rolled it out yourself, right? You're not using Okta or something.
No, we're not.
I see.
Yeah.
Okay.
We use, yeah.
You just implement. I see.
Yeah.
I see. So you're using Okta for the auth. I see. Okay. All right. I just learned something today.
All the questions. Once again, thank you to the audience. Thank you to the panel. And I think when I moved to Silicon Valley a while ago, I think what I noticed over here was just the spirit over here about how everyone's just willing to help each other. Everyone's willing to take a hand and helping you learn. And I feel like that's what we're trying to build as a community. And we invite you to be a part of it. Everyone on the panel that I've met here has been through some of the other interaction. And I just think that I'm just surprised, pleasantly surprised that this positive experience over here. And thank you so much to everyone.
I'm happy to connect and answer.